A man walks in a straight line from A to B at constant acceleration of 0.004. His speed at A is 1.8 and his speed at B is 2.2. Find the time taken for the man to walk from A to B and the distance from A to B. Okay, so equation of motions can be used here since acceleration is constant in this question and since it's a straight line motion. So to find T, we can use V is equals to U plus AT. 2.2 is equals to 1.8 plus 0.004T. This gives us T is equals to 100 seconds. And we need to find S. So I'm using V square equals U square plus 2AS. So 2.2 squared is equals to 1.8 square plus 2 times 0.004 times S. S comes out to be 200 meters. Okay, part one is done. Part two says a woman cyclist leaves at A at the same instant as the man. Okay. She starts from rest and travels in a straight line. She is also traveling in a straight line, reaching B at the same instant as the man. So the man reached B at time is equals to 100 seconds. So this woman will also reach B at 100 seconds. Okay. At time t seconds after leaving A, the cyclist speed is this. Okay. So since the cyclist speed is dependent on t, so its acceleration is also going to be dependent on t, which means it's not constant. That means we cannot use equations of motion here. Okay, find the value of k. Okay, so how do we find k? We know that when this journey of the woman cyclist completes, its time is also t100, sorry, yeah, 100 seconds, and the journey is from the same spot A and B, so the displacement or x would be 200 meters as well for the woman. So we'll find the expression for x first, which will be integrating this. So let's integrate. X will be equals to 200k t square upon 2 minus k t cube upon 3 plus c. Okay. Now we need the value of c. For that, we need a pair of t and x value. Okay. So from the question, we know that when time is 0, the woman is at A. That means there's no displacement. So when t is 0, x is 0. When you substitute it in this equation, you get c is equals to 0. So you can just get rid of the c. Okay, now we know when x is 200, t is 100. I'm going to take k common here again. So this would be 100 and t is 100 as well. Minus 100 cube upon 3. Solve this and get the value of k. Okay, this gives k equals 0.0003. Okay, k is found. Now it says find the cyclist speed at V. Okay, this is cyclist speed. Find the cyclist speed at B. Okay, so this is the expression for the speed, and we know that the journey time is 100 seconds, and now we know the value of k as well. So V will be equals to, substitute the value of k and replace t with 100. This will give 3 meters per second. Sketch using the same axis the velocity time graph for the man's motion and the woman's motion. Okay, so velocity on the y-axis, meters per second, time on the x-axis in seconds. Okay, so we know u, v, and t. For the man, u is 1.8. That's right, 1.8 here. V is 2.2. So let's write 2.2 here. And time starts at 0. And the journey takes 100 seconds. So I'm writing 100 here and making a dot here and joining this with a straight line. This is the journey for man. Okay. And now for the woman, at time 0, the uh, velocity is 0. And at time 100, her velocity is 3. So I'm making a mark at 3. Now, since this is quadratic, so this will be joined with the curve, a smooth curve, something like this. Okay, this is the velocity time graph for the man's journey and the woman's journey.